Okay, with problem number 10, we're given this triangle ABC that's not shown, and we have a length of side AB as 12, and the length of side BC is 9, and the measure of BAC is 30 degrees. Well, I'm going to start this by making a diagram with an angle with a side of length 12 that is rotated through a 30-degree angle. Now, this side, the vertex over here would be A. The vertex at the top would be B, and the vertex on the right side on the bottom would be C. Now we're told that BC has a length of 9, and we're looking for the length of side AC. So that's what we're attempting to find here, is the base side of this. Now there are a number of different ways of looking at this problem. One way that I would not neglect is the very simplest way if you see it. First of all, knowing a 30, 60, 90 triangle, you know then that the smaller side is the side opposite the 30-degree angle, and that the hypotenuse of that 30, 60, 90 triangle is twice the smaller side. And finally, the third side would be the square root of 3 times the smaller side. And that's what I also call a 1, 2 square root of 3 triangle. 30, 60, 90 is going to be a 1, 2 square root of 3 triangle for the sides. Now, we could apply that principle over here because we do have a 30-degree angle here. Now, one way we would know the side C is if this were a right triangle. For example, if BC were perpendicular to AC. But in order for that to happen, side BC would have to be 6. And it's not in this case, it's 9. So it's longer than the perpendicular BC to AC. And since we know that that side is 9, we can tell in this case that it can't be a right triangle. If it were a right triangle, we could find the opposite side fairly easily using the Pythagorean theorem, but we can't do that here. Now, since it's 9, another thing that's very important is that it could be this side over here, the one that I've labeled 9 there, but it could quite conceivably also be this other side, length 9, that has a different angle. So you should see that there are more than one sides, more than one way we could draw that BC side there, since it is larger than the perpendicular to AC. And because of that, there's really no way, just by looking at this much of the picture, there's no way that we can tell what the other side, what side AC would be. It's either going to be the one that connects to the obtuse angle formed by BC, or it would be the one that connects to the acute angle formed by BC. So there's no way to tell what that angle is from this information. So this is one way of solving this problem. And in this case, if you were to see it, it very well might be the simplest way of solving this problem. And the answer would be D. It cannot be determined from the information that's given. Now, if that side, BC, were longer than side AB, then it couldn't swing either way like that. So there would only be one solution. And if it were exactly 6, there would also be only one solution. But we don't have either of those cases. We have a value that's between 6 and 12. And so the value between 6 and 12 could swing either way, and it would be an ambiguous case here. We don't know which one to use, and so the answer is going to be D. In subsequent videos, I'll look at different ways of solving this particular problem using the law of sines and the law of cosines. But I would suggest that this is the simplest way, and pick up the important principles from this problem that you might apply in similar problems to this.